So probably we can start now, Cecile.
Yes, great.
Okay, so then welcome to everybody, and thank you so much for your interest and your participation in this workshop, which is part of a process that we will see very shortly in a couple of minutes. We are quite a lot of people, because we had 40 registered participants, and then we are almost already 40 people in the workshop. So we thought that we are a bit too many to make a tour the table and to introduce each other, but we have just made a general slide simply to present altogether all of you and your participation from the Biodiversa partnership, quite in a large majority, and then from both the national institutions that are working on biodiversity data monitoring and databases on the European and global initiative, the European Commission institution, and then other number of institutions that involve a few very relevant projects and initiative and other national institutions. So if you move to the next one, thank you so much, Cecile. Then a short view to the agenda of the meeting, and then we have this short introduction, and then the keynote speech on data interoperability and harmonization for biodiversity by Anna Koivula, and then the Metternet and Flemish method, data architecture and data workflow by Dimitri Brossens, German NFDI for biodiversity, data architecture and data workflow by Barbara Ebert. And then we are going to split in subgroups, and thank you so much, Cecile Mandon, for introducing the subgroup activity, and then we will have quite an intense discussion in subgroup and all together in a general discussion. As you see in the agenda, our time slot is more or less divided into two blocks, one with the introduction and presentations, and the other is in the discussion in the subgroup. So the next, the aim of this activity, is better understanding on the data architecture and operating data flow in a national, subnational level, and the exchange with different actors with the level of harmonization and interoperability in different databases. It is a relatively small component of the whole process for making standardized and integrated the monitoring process of biodiversity at European level. So it's just a component of the process. Actually, the point of the component is that it's the component that manage to make what every one of the national nodes do, and every one of the research groups do, visible to all other researchers, to the institution, to the citizen, and also reusable and accessible to both scientists and all other type of stakeholders. So it's a small section, but which is quite relevant in order to make a more efficient use of the data that are going to be collected and that are collected, and also the information that we can build on the data and the understanding that we can build on the data. That's why we have organized this activity. And then we will also discuss on how Biodiversa Plus could launch concrete activity to further improve data interoperability and harmonization. That is another big issue that we are going to have. And in this process, we need to thank a lot the different groups and initiatives that are contributing to this activity, well, from the national, European, and international level, the different initiatives, and particularly the connection that we are having with a few key projects and initiatives at the national, at European level as Europaborn, and then with the European research infrastructure that are referring to the biosphere domain, that are actually active on the different component of the whole process, from monitoring to giving accessibility and harmonization, interoperability of the data in the data domain. So if you can go to the next one. Okay, then just a few words in order to introduce all of you to in the context that we are of this activity that is started basically on May this year with the organization of the working group, and then through the activity of the working group with the first workshop that we have held on the 1st of September, mainly focusing on the activity of the European and global initiatives that are mainly active on the specific aspect of data harmonization and interoperability as the few major projects or initiatives working on the e-science component of monitoring biodiversity and ecosystem resources. So the meeting has been, I said, the participation of quite a lot group and scientists. We were 37 participants at the meeting, and then there was quite an intensive discussion, participative discussion at the meeting that has highlight a number of points, both in terms of what we need and what Biodiversa Plus can do. And on that point, we built a bit more, circulating a survey that was addressing all the Biodiversa Plus partnership in order to have comment from a larger group of stakeholders on the outcome of the first meeting. And then today, we are going to focus a bit more on the national and subnational level and on the monitoring processes. The process will go on with a report on data interoperability and harmonization, which also involve a mapping on the database and data resources that we have at the European level, and that represent a deliverable of this activity. Then we will proceed and go on forward in 2023 with the launch of activity and action to support data interoperability and harmonization. So that is a process that is ongoing, and then we really hope that we will have your participation and collaboration through all the process. And I'm sure that many of you were also attending and participating to the meeting on the 1st of September. The next one, please, Cecile. That is just a very short overview to give you the idea on what we have done with this participative activity that was addressing a few points. So the need of standard, capacity building, and governance. And these were the issues that we need to tackle, and the critical aspect that they're dealing on the different component, from the need of standard, the new technology, the need of better capacity building and of stronger and more distributed governance process and best practice activities. As you will see, there are many points that have been raised, and many points have been raised also on the aspect that we're dealing with what we also as a scientist expect from Biodiversa Plus, and the support that Biodiversa Plus can give to the research group and to the research community in Europe. If we go to the next one. Oh, yes, before than that, we made this survey, and as you have seen, the comments that we got from the Biodiversa Plus partnership with 31 respondents to the survey was basically supporting the different points of priority that has been raised into the first workshop, and most with a bit of stress on those that were dealing with the governance and the capacity building, that, as you see, were highlighted as very important from a large majority of the respondents. Then you can go to the next one. Thanks. Well, same process has been done on what we should expect from Biodiversa Plus, again in the three components, standard and new technology, best practice, and then governance. We are highlighting this point since the very beginning because Dennis also is going to be a starting point also for the discussion that we are going to have in the second part of this meeting. And then you will see that in this case, for both standard and capacity building, there are different ways in which the participant has highlighted the potential of support from the Biodiversa Plus activity. And then if you can go on again. Yeah, and that for the governance, it was the same. It's facilitating the integration, they coordinate the interaction system between organizations, because of course it's a work that we are trying to do with this action is exactly to put things together, to try to connect the different components from the national component working on the monitoring process to the international project, international activity, and the research infrastructure that on which Europe is actually pushing a lot of stress and is expecting a lot of important results. So if you can go to the next, even in this case, there are generally quite a large agreement on the different points that has been raised, with some of the components that were still to be probably more clearly raised or emphasized. And then just the next one. So I think because I took already a lot of time, and then just to give you a overall view on what was the support from the surveys, that there was a general agreement on the issue that has been raised and that has been proposed in the first workshop, both for the main issue to be tackled and then for the support that Biodiversa Plus can give. The last one of my introduction, and then what we are going on, and we are going to be the next step. There is going a public report showcasing this national and global architecture and workflow that will be drawn. And the objective will be to have a better understanding on the landscape, including the gap, identify the case study and enabling capacity building and knowledge transfer, identify good practices, and also give a very synthetic overview of which are the most advanced technology that are going on in both aspects of harmonization and the interoperability of data and dataset. And then we will build on the relevant activity that has been achieved by Europabon project, with which we have a very strict collaboration. So thank you so much. I don't know if there are questions, but I think that we can go on with the next one probably, and we will give the floor to Petteri.
Okay, thanks a lot, Alberto, and thanks everybody for joining for this workshop. So I'm Petteri Vihervaara from Finnish Environment Institute and leading this work package 2 of Biodiversa Plus about biodiversity monitoring on behalf of Ministry of Environment Finland. And it's really pleasant to see so many participants in this second workshop. And I'm just going to give a very quick overview how this work, what we are discussing today, relates to the general development of this biodiversity monitoring development of the Biodiversa Plus. So Biodiversa Plus is like a national network counterpart for the Europabon, as Europabon is designing this European biodiversity monitoring coordination on behalf of the European Commission. So we are providing viewpoints from the national networks, as most of our partners are representing ministries of environment or environmental protection agencies, and try to support this joint development of this comprehensive European biodiversity monitoring landscape in the coming years. So our work package is divided in 5 different tasks. The first one, task 2.1, is focusing for the different monitoring priorities, which are of course embedded by the different policies and policy implementation, like nature directive reporting and so on, and implementation of the biodiversity strategies. Also indicated development is part of this task. These are feeding in for this more technical development of the task 2.2 and 2.3. 2.2 is this one where we are discussing today. So it focuses on harmonization of protocols, methods, databases, and so on. And then task 2.3 is parallel to that, focusing more for novel technologies like remote sensing, eDNA, so on, for monitoring techniques and citizen science approaches. And then finally we have task 2.4, which is like an endpoint of all the monitoring data. And there we are focusing for different use cases of biodiversity monitoring data, for both for research cases, but also for policy and societal decision making, private sector as well. And then under all of this, we have this rather comprehensive task 2.5, which aims at building on the work of these 4 other tasks, and to build up a network of biodiversity monitoring schemes and a working collaboration between different networks from the transnational point of view, but also in collaboration with these European and international initiatives. Next slide, please. So basically the way how this work could be supporting Biodiversa Plus development and vice versa. One thing is that as Europabon has been already paid attention for this different data workflows and developing EBV approach for European biodiversity monitoring development, we hopefully can maybe enrich this approach and work in collaboration, and also improve the availability of raw observations, indicator data, different national data sets, so that there will be smoother data flows from these national data storages, databases to the European level demands. What we are aiming to do is to map what is going on in different countries, nationally or subnationally at the moment, learn from the best practices of data architectures, and also support capacity building of those countries who are just approaching this venue and these topics. Yeah, and hopefully this capacity building will be then continued, and also in close collaboration with other tasks. And then one quite crucial thing, what has been emphasized already in Alberto's presentation, is that open data, fair data, and standards are really important. So we really need to exchange information on those to get our networks and collaborators to understand what is needed from this topic of the data interoperability development. And of course, that's very much in collaboration with European Union plans for digitization strategy and digital futures. And then we also are working in close collaboration with different research infrastructures. Maybe you know ELTER infrastructure, LifeWatch infrastructure, GBIF as kind of infrastructure as well. So they have already developed good practices, and it's very important that we learn from those what is needed for this more general biodiversity data development and interoperability. And finally, I would like to mention that the concrete way how Biodiversa partners and their third parties, collaborators are going to develop these things. We are going to launch in the beginning of next year so-called pilot projects where we have allocated 3.5 million euro funding for the next year through the Biodiversa and European Commission to the partners and their networks. And we are mainly focusing for 3 different sub-pilots. One is focusing for species monitoring schemes, particularly this time for invasive alien species approach. Second sub-pilot is focusing for habitat monitoring schemes, and there we will focus first in the soil biodiversity, and maybe it will follow up next year with a more general habitat condition pilot. And third is more focusing for this governance, interoperability issues, and like a data standards. So that will build on these 2 topical sub-pilots, and also state of the art what's going on in different countries, so that will provide opportunities to continue work started today and make a closer collaboration with our national networks and collaborators to maybe improve the things what will be discussed more today as well. So I would like to welcome everybody for this meeting and happy to follow what will come up. Thanks for participation.
Thank you so much, Petteri. And then, if you agree, we will give immediately the floor to the keynote speaker, and then to ask Anna Koivula to take the floor. If there are burning questions, of course, we are open to reply, but otherwise we will bring everything to the general discussion and leaving the floor to Anna.
Many thanks. So my name is Hanna Koivula, and I work currently at the Finnish IT Center for Science, CSC, which is government-owned non-profit enterprise offering services for research infrastructures. Petteri kindly invited me to talk here about data interoperability and harmonization for biodiversity. And I need to apologize a bit. My talk is more aimed at the grassroots level, researcher collecting monitoring data, but I think I will skip the later part of my talk and leave some space for discussion, because I find this is important, and I hope that you get the idea from my talk what are the challenges and possibilities for biodiversity data in general, or in interoperability of biodiversity data, and we can talk about the infrastructure part then afterwards, because yeah, now I realize that my scope was a bit biased here. So I start from the FAIR principles that are self-evidently familiar for this crowd to make research data findable, accessible, interoperable, and reusable for humans, and especially for machines. And this was introduced in 2016 for research data to tackle the so-called reproducibility crisis. And it's thought that by making your data digitally reproducible, it makes possible also to replicate the same process with different kinds of data. And this also leads to reusability of the data. So you can use repurpose the data once collected. What is research data? I include this is from one of the article and I need to find the reference for it, but this is a good way of categorizing research data by if it can be referenced or not. So there are multiple different places where you collect raw data in digital format, and that's called operational data. But operational data, its purpose is to be up to date and be able to collect and disseminate the data, but it's not research data because it's not versioned, documented or validated. So to make it into research data, you need to have a process where you kind of standardize and harmonize that data source internally to make it research data. And then when a researcher does an analysis and writes a research paper, there can be takes from operational data sources, multiple of them, and also from generic research data repositories or databases. And this process of collecting the data and compiling it into a research data set must be also documented and versioned. And this static immutable data set is then published with the research article in a repository with a metadata and a persistent identifier. But these three things will come up in my talk later. So when the data is harmonized, it's made to be fair and interoperable. So interoperability means it can be integrated with other data applications and workflows, and this is achieved by using common metadata and data standards and harmonizing the data variables or elements using semantic artifacts, which mean controlled vocabularies, ontologies, thesauri, and other similar things to describe the variables unambiguously. And then we have also technical interoperability, which use more strict technical standards and APIs for data workflows and data transfer. European interoperability framework divides the interoperability concept into 4 layers, which are legal interoperability, organizational interoperability, technical interoperability, and semantic interoperability. And all of these would need to be also machine actionably interoperable. So you have to also express, for example, copyrights or licenses in machine actionable way. And organizational interoperability is also important aspect between different kinds of research infrastructure, so that you talk about the processes or the processes are machine actionable, so that you can compare and integrate processes between the research infrastructures. Technical interoperability is easy to understand. That's how we normally talk about data formats need to be interoperable. So you need to have kind of open formats so that you can map technically the data between different data sources. And semantic interoperability is about the content, how to interpret the content of the data and how it's organized, what's the structure of the data. FAIR principles were originally implemented for research data only, but there's a increasing tendency to also try to apply FAIR principles to other digital research outputs, like the processing codes, or models, or metadata, result data, raw data. What all comes out of the workflows are missing from that picture. So for the biodiversity data, or this is not always possible, but the minimum requirement for becoming FAIR is the so-called shallow FAIR, where only the metadata is interoperable and standardized, and it has machine actionable license and a permanent identifier, but the data and other documentation behind the metadata can be in raw format or minimally standardized, not machine actionable at all. But if you want to do more than just to connect the author to the research paper to the data set it used, then you need to go to the deep FAIR, meaning that all the data elements are machine accessible inside the data. The problem here is that this is context, binded to the context. So you can have the raw data and describe it very richly, but not all the data items can be standardized depending on what the purpose of the data was originally. And for the biodiversity data, this creates some challenge, because biodiversity, from the researcher's point of view, when you search for data, you normally want to find out whether certain group of species were abundant in an area during some particular time frame. And you can't list all the species you have in a data set to the metadata, or then it's a complete checklist, which may be as big as the data set itself. So this is why biodiversity data is mostly searched on data level, not from metadata, discovery metadata. And you need, for biodiversity data, metadata has an important role, but it's not discovery. It's more to do with the data quality and whether the data items you have gotten in your search to the data collection are, if each of these data sets that are included into your data compilation are suitable for your purpose. So you need to find out about the methods used when collecting the data. And also the data quality needs to be described for the original purpose, so that because data quality is very dependent on the purpose, and this is a decision that the researcher needs to make when they search for data to be reused. And this data level interoperability is called deep FAIR. For biodiversity data, this is how GBIF is doing it. So biodiversity data can be collected for many different purposes. So it originated, or the original start for it was the digitized specimens from museums collections, but growing number of data comes nowadays from observations, and these observations are based on some evidence, but the evidence can be different kind of evidence. So it can be a digital photograph or sound file or some other documentation of the observation which holds the evidence for the occurrence itself. You can get occurrence data from literature as well as and remote sensing, or from DNA. And all of these data sources have different quality assurance and different ways of describing their internal interoperability. So if you collect these, compile these into a data set that can be searched globally, then they need to be harmonized for those elements that are going to be searched. So GBIF does this with Darwin Core Standard and ecological metadata language, and then some of the data elements are indexed to gbif.org, which is the place for the global. Oh no, my screen was frozen for a bit. So GBIF is a data aggregator. It's not actually a data repository in that sense. So it connects to the original data source. It interprets the data with DAWINCORE standard and ecological metadata to be searched from gbif.org and to be accessible to the data user. Data user then needs to go through the data download and check whether the data items inside it are usable for his or her purpose. And if the data looks interesting but not complete enough, then they may contact the data originator and ask if a richer data set is available. One point here is also that GBIF downloads can be cited with a DOI, which holds information of all of the original data sources that are included into the download. And this way the originators can follow up their data usage through GBIF. Why do we need standards? I understand that this is self-evident for this crowd, but standards are needed for this harmonization, and they are also used for quality assurance for this purpose. And then in combination with the standards, vocabularies are used to express the data quality as rich as possible. And these standards and vocabularies make the data into deep fair, data level fair. GBIF has 4 different layers, or it supports different layers of richness in the data. So in the minimal format, you can have EML metadata available and then the raw data published as a raw data set behind it. So this is the shallow fair. Then GBIF speciality is the list of taxa. So you can also publish species checklist for invasive alien species and for example, or medical species lists, or also national or European regional endangered species are one checklist also, which is officially governed in a EU level and nationally. Then there are species occurrences datasets, and the most newest thing in GBIF is sampling event data, where also species occurrences and sampling events like dates, coordinates, sampling efforts, and protocols are documented, and the data elements are tied to the event. And I assume that this is important for monitoring data especially. And you can also publish the data first with only metadata and then later enrich it towards describing the data structure with the event, or have the checklist accompany the occurrence data set. So all of these are possible at the same time. DAWINCORE and its extensions are maintained with the so-called TADWI community, which is the Biodiversity Information Standards community. There are currently 34 registered extensions that are official and maintained, and then the community is working with new data, with new extensions to DAWINCORE. One of the most interesting ones is Humboldt Core, which is for species inventories. And also there's a newcomer for the camera trap data, and iNaturalist platform will hopefully also have its own extension, which will be then used as a data kind of publication profile. And it's very recommendable to participate into the development of this if you have expertise on, for example, the species inventories, because now it is possible to have an effect or take part to the dialogue. What aspects are problematic and how could they be solved in these standards? So this is an example from measurement of fact extension, where the standard itself has some controlled vocabularies. Here, for example, the basis of record can be from the source, can be occurrence or organism or material sample, event, location. So you can choose from the standard controlled vocabulary, but then you can also use external reference data. So you can have external vocabularies used when then in more detail describing the measurement type and what kinds of values it can have. So these extensions allow flexibility, but then you can also have more detailed information in them by using vocabularies. And actually, I think I will skip this part because this is to explain how the vocabularies work. But in principle, you need to differentiate between the concept in the data element from the term that is being used, because machines don't understand. If you talk about plants, machine don't understand whether you mean a power plant or a living organism, and this needs to be modeled so that machines also can differentiate between what's the context. Humans can understand the context, but the machines don't. Yeah, so I skip that, and we can talk about it if it's interesting, how to use ontologies or vocabularies, but maybe it's more important to offer places where you can find these controlled vocabularies or ontologies and then use them with your databases. I'm also currently working with the ELTER network or ELTER Plus project, and we are now trying to survey what all kinds of standards are needed for the environment part of the data, which may also include biodiversity data. And ELTER project is promoting and building forward the NTES vocabulary, which could be of interest for the monitoring data community in biodiversity also. And then need to mention the GBIF taxon backbone, which lists currently about 100 species lists from around the world, and this is maybe the best place to see whether there would be a checklist that could be used with a database dealing with the biodiversity monitoring data. Then there are official data sources for land cover or habitat types, and there's also a granularity issue with these. So European level data needs to be harmonized at the European level, but it may be more practical to have more granular, expressive reference data nationally, and then harmonize that to the EU level to be searched also for other parts than biodiversity data. So databases and input tools are the place where these data harmonization things are to be implemented, and they can help so that you can have these vocabularies inbuilt, and the data ingestion happens already in harmonized format, but and they can be used for validating input data. They help interpreting and capturing locality information, and they can have this checklist of taxons readily inbuilt in them. And you can set them to use the local, which can then be local granularity level, which can then be harmonized to the regional level later. And these tools may draw metadata automatically from sensors or image files, which is a great asset when you use iNaturalist, for example. But then there are some risks involved. So automated data validation or data assurance tools can also do errors, and then if those are not noted in time, then it can start creating biases. So it is important to keep the original raw data. And also original coordinates can be, should not be discharged even if the tool offers interpreted and harmonized data, because there can be, these errors can be visible only from the non-harmonized data. And it's impossible then to trace back if there are errors, if it's harmonized and the original raw data is being discharged. Also, having automated list is a risk, because it can start biasing. There can be typing errors which start then creating a bias if you input data in an automated way, and this may be difficult to notice. And also it can cause false accuracy. So you can have the device to tell that this accuracy, or that it can give those coordinates in 1 meter accuracy, even if the real accuracy would be 1 kilometer or 10 kilometers. And that's also dangerous if you do research. So it's important to keep the raw data raw and harmonized only for interpretation and reporting, or combining with other data sets, but always still have the original version available. So this was my talk, and I'm happy to answer any questions. I hope I didn't take too much time. Thanks.
Thank you so much, Anna. I see a number of hands raised. I don't know, Cecile, if you want to have some question and answer now, and then we have a dedicated section at the end. But if Petteri and David want to make a quick question, that will or comments, that will be, it is great. And then I see also Mark, who has the.
Alberto, maybe we can keep the questions, if this is okay for the participants. You can keep the questions for the Q&A session that we have after the presentations, and you can come back also on the presentation of Hannah, so that we have all the questions together. And also feel free to talk in the chat if this helps.
No, that is fine, Cecile. You are right, because you have a dedicated question. Just if there is some burning question that absolutely need to be done now, then we can have one short, and then we will continue at the very end. I see that Mark still has the hand raised, so if you want a very short question, Mark, and very quick answer, and then we are going to continue.
Okay, Alberto and Cecile, thanks, and Hannah, thanks for your talk. It is in a way urgent, because I have to leave in a few minutes for a different meeting, and therefore I would like to ask Hannah why you said that metadata in this context you do not regard as that important. And the background is that actually we are working on metadata standards for biodiversity monitoring within Helmholtz metadata collaboration project. And therefore I just want to know if we can skip the whole project because it's not important.
No, please don't. I'm not saying metadata is not important. It's not just used as discovery metadata for the biodiversity, the species part of the data. So it's very important for you to actually have the metadata to describe the monitoring scheme and all the things that cover the whole data set. But when you do when you try to discover species level data from compiled biodiversity data sets, then you need to start from searching the species level data level, and then you go back to the metadata to see if the data you've discovered is usable for your purposes. And this was the beef of my talk. So hopefully this clarified. Thanks.
Yeah, okay, thanks. And it was simply a misunderstanding from my side. Thank you.
Thank you so much, Mark and Anna. And thanks to Cecile for reminding us that we have this session. So I'm going to give the floor to Dimitri Brosens for his presentation.
Hello, good morning. I'm trying to share my screen. Is this okay?
Yes.
Good. Good morning, everybody. I would like to talk to you a little bit about meetnetten.be, which would translate literally to measurement nets, networks.be, but we'll call it monitoring networks for the rest of the talk. So monitoring data on European and Flemish priority plant and animal species. So I'm Dimitri, working in IMBO, Research Institute for Nature and Forest in Brussels, in Belgium, in Flanders. This goes about Flanders, so sub-country level, I would say. So meetnetten.be, measuring networks, what is it? It's a suite of monitoring networks where we try to collect high quality information on about 78 priority plant and animal species for Flanders. These species are the species where we have to report on, for example, for habitat and the bird directives, or species that are important for the Flemish nature policy. And this is mostly species where already a protection plan is available. This monitoring networks initiative is a cooperation between the Agency for Nature and Forests. This is an agency from the Flemish government dealing with all nature reserves, etc., and the planning and the policies. Natuurpunt, which would translate to Nature Point, which is a local NGO. We have a lot of volunteers, so we need volunteers for this measuring network of monitoring networks, and our institute, the Research Institute for Nature and Forests. We started it in 2016 and it's operational since 2018. Most of all the data is collected by trained, stress on trained citizen scientists and professionals. We do record, but actually not for the purpose. It's the casual observations. They are important, of course, but they don't do the trick for exhaustive monitoring and reporting. And the whole tool is developed by Zostra, which is a Dutch company developing a lot of tools in this biodiversity area. The monitoring networks are based on fixed sample locations. There are target species, and they are counted based on standardized protocols. So every species has a standardized protocol which the volunteers have to follow when they go in the field and record all the data. So the volunteers are specialized, coordinated by Natuurpunt Study, which I already said, and the field work is planned by the tool, which I will very briefly present, and it's called, it's the URL meetnetten.be, and it's also used for entering the collected data. This is an example of a monitoring network. If you go to the website, which I'll show you in a minute, you get appointed some places where you have to go. This is very high detail. So this, you see the arrow, I guess this is a community of municipality in Belgium, where there are some transects written on the map, and the volunteers exactly have to go there to do their monitoring tasks. This is for every priority species in meetnetten monitoring networks, different, of course. This is the website. Unfortunately, it's all in Dutch, so I will not bother you too much with all these Dutch languages. There is a welcome here, welcome to meetnetten, and these are all the projects which are listed where you can choose from if you, as a volunteer, want to be part of this. So there is about odonata, plants, butterflies, bats, other mammals, mollusks, birds, and other things. When you're on the tool, you have a dashboard. This is my dashboard. I'm not participating into the monitoring, but I have an account. Locations you can choose. You pick a location. This is my responsibility. You go there, you do your work, and you're networking. Details, tasks, visits, observations, and you can export the data you've been collecting, of course. The goal of all this monitoring network is to define to get to know the long-time trend for a number of individuals, the population size in Flanders, the distribution of the species in Flanders. Of course, this is not only about the data collected in monitoring networks, but also casual observations like coming from waarnemingen, which is a counterpart from like iNaturalist or iNaturalist in Belgium. And we want to create valid complex models based on the standardized, stress on that again, field protocol. And the protocols are based on a defined counting period. So you have to go to a certain place at a certain moment in time, a defined count frequency, a defined time, and defined locations, as we saw before. How it works. This is an overview on the first part, setting up the network. There is an admin here. He creates a monitoring network, and he will point out to a network monitoring coordinator. He defines the field protocol, which species should be monitored and which locations. Then the coordinator will find volunteers through the websites. There's working package, which will be a task which will be created. So the fieldwork network coordinator will align all these things. And then there is the citizen scientist, very important part of this initiative. He needs to register on the site. He needs to say, okay, I want to be part of that monitoring network. He needs to make a reservation of the location. He will do the field work, and he will give the results to the tool on the internet. This is from building a monitoring network to the data imports. Then all this data goes in a database. It's a very large database with a lot of tables and a lot of relations. I will not bother you too much with this one. But then what we need to do is to make sure that our data gets to the researcher and gets published. We have a lot of different ways to do this. First of all, we created a star scheme model of the database, a data warehouse, which makes it much more easier for all our scientists to query and to find the data they need, star scheme. So we can connect in the institute to all the data which was collected by the volunteers through RStudio or with an ODBC access protocol. We will also disseminate our information to the Agency for Nature and Forest, ANB, by a map service in high resolution. And we will also publish all our data to GBIF through the integrated, the IPT, the Integrated Publishing Toolkit, in the Darwin Core standard, which was already mentioned by Hannah. And that data will be available for all, but unfortunately, it's a little bit in lower resolution. This is because agreements with the nature, with the NGO, etc. So we are not allowed to publish everything on high resolution. For a lot, we do that. Also, we are monitoring in military areas where the commander said, okay, you need to use a 10 by 10 kilometer grid. So we need to deal with all these issues too. For IMBO, we have created some packages to make sure that our scientists can connect in RStudio to the database. They can simply connect, and they can look at all the tables, make relations. They can also use SQL in R to query the MedNet database. So that's quite easy if you're proficient in R. So the whole SQL statements can go in R. Also, a lot of scientists are still using Access. So there is an Access to Access where you can exactly do the same to connect to the data. And for our partner IMB, we create this map service giving the data on a high resolution where you can look at all the species, pick the species, and look where they are found and how many and in which year, etc. Also, we've been, we publish all this data to GBIF. GBIF was quite well explained by Hannah. before, and I guess most of you already understand or know a little bit what it's going about. Also want to say that I agree with the metadata question. Metadata is from utmost important to describe a data set, but if you go to GBIF, you mostly look for species, for areas where you can find animals or plants in. So we complete the metadata. It's a long and it's a well-documented process. First, there is the data publication team, starting with an I don't know for the moment the English words, a draft, a draft to the metadata, looking at the website, looking at the species, describing, taking a lot of work out of the hands of the scientist who needs to validate and check of this. There's one thing we learned: giving an empty page and saying describe the metadata, you won't get anything nice back, if so to say. But if you give information you have and there will be errors in it, they will be very eager to correct the errors you make and make sure that the metadata is well written. So we make this draft, we give it to the monitoring network coordinator to check it, and then we copy actually the metadata in the integrated publishing toolkit, a toolkit from GBIF, which is used to publish the data on GBIF, and the metadata is described in the ecological metadata language, which is in XML format. You see here, this is what I written, and this is my colleague, the network coordinator, saying, maybe better to use this wording, or maybe use this wording, etc. What do we do next to make sure this data is published in a good way on GBIF? We map the data, which is not created in Darwin Core. It's created, a big data model is created looking at the whole idea of the measuring of the monitoring networks. After that, we started to create a translation and map it in SQL to Darwin Core. Yeah, what is maybe interesting or not so interesting to say, I had to say that we had to make a higher resolution data available. A lot of the work actually goes in making the data less, in a much less higher resolution. So that's also unfortunately that a lot of the work goes in there, but that is how it goes. We map this data to the ETCR sample of event-based data. So we have an event core that is the table telling you where do you go, what time, what protocol has been used, etc. Then there is an extension on this event core saying, I've been in this event, I've seen these and these and these species. That's the individual count, that's the life stage, etc. And then in certain occasions, there is also a measurement of facts extension attached with some variables which we cannot provide in the other tables. Then what we do is connecting the data from the IPT to GBIF, because we did all the Darwin Core mapping in SQL already before. This is quite fast and automatically. So we make a connection. This means that this data can be also updated quite easily, and even if you want, in an automatic way. We publish this data. There is an update we do every year, because there's a whole process between going to the field, getting the data, and validate the data. So in the end, we publish this on GBIF. This is an example from meetnetten.be transect for butterflies in Flanders, Belgium. 51,000 occurrences already available there. We register the data to GBIF and we publish the resource. Because we use GBIF, you can go there, look for a title in the meta. That's the metadata is important. If you look for that, you can look for MeetNetten. Metadata is important, but also because we use a collection code, MeetNetten, we can get in GBIF all the data from all the monitoring networks at once, and also through the API, this becomes available for others to use. Of course, this is an aggregated data set. If I would click on this one, and for the ones looking at the presentation later, I've put it in some links which will work and give you the example. You will get through the API of GBIF, you can get everything together in your tool, which you would like to use to do some research or find some trends, etc. in the data. This whole process we also document on GitHub. Also, we provide in the metadata some links for issues. So if people have issues, questions, etc., they can easily connect us to discuss what was wrong, what went right, etc. As a quick review, the method steps, what we do for publishing on GBIF is that, and the first half is of course the same as for the data in the institute and for our partners. So researchers from INBO in Natuurpunt study, the NGO, define and document the appropriate sampling protocol for the target species. Fieldwork is planned and coordinated by Natuurpunt, so that's what they do, using the tool, the online tool, metmeta.be. Then data are collected in the field by specialized volunteers. So I stress again that they need to follow some kind of a training to be proficient in the monitoring network protocols, and they're using a predefined sampling protocol. The collected data is entered in the database through the web application. Then for GBIF, we create this custom SQL view for mapping to Darwin Core, connect the IPT to GBIF, and the dataset is published and registered with GBIF. So in the end, MateNet is a quite big endeavor with a lot of partners, a lot of persons, where I would like to acknowledge everybody who's here and the hundreds of citizen scientists, of course, who are helping with this monitoring network. Voila, that's what I had to say. So if there are any questions, I would be happy to answer or try to answer them.
Dear Dimitri, thank you so much. Really, thank you so much. We are a bit late, so I suggest to leave the question for the question answer session, and then to proceed with our last presentation in this first section, and then I will give the floor to Barbara Ebert.
Thank you very much. I'll share my screen. So you see the presentation mode, is that correct?
Yes.
It is fine,
Very good.
Barbara.
Yes, thank you. So yeah, thank you for inviting me to speak today. I'm the executive secretary of the German initiative NFDI for Biodiversity. I'm a science manager and no data specialist, so but I can very well pick up with my talk on from Hannah's talk, because we are also from the science sector, and we approach things in a similar way, I would say. So we're a consortium of 50 organizations, from research institutions and scientific IT service centers to natural history collections and civil society initiatives. So we have citizen science, collections of occurrence data, similar to Dimi's presentation. A couple of those initiatives as well. I think you could describe us as a practitioner network or community of practice, where the partners are uniting their efforts in a 5-year work program. Important to note, the work is funded by the Joint Science Minister Conference in Germany as part of the National Research Data Infrastructure. Our consortium is transdisciplinary in nature, so we have partners from science and from public service, from the public sector, and we are dedicated to mobilize data and roll out new services for the wider biodiversity community. Many of our partners already run tried and tested services. So our strategy is to use the available professional, scientific and technical resources in order to help users from different fields. So this could be science, politics, nature conservation, and landscape management, to deal with biodiversity and environmental data. And being part of the National Research Data Infrastructure helps, because we also have consortia who deal with Earth system data, and we connect to those. And we also have a consortium with social science data, and we see that a lot of research projects being done in biodiversity also deliver interview data or other types of data that we do not directly deal with in our in our consortium. So the overall goal is to help these stakeholders make better contributions to the conservation of biodiversity based on reliable data. In this, we rely on we adhere to the FAIR principles. So we strive to make data findable, accessible, interoperable, and reusable, using many of the same approaches that Hannah already described. Another principle is we work with concrete use cases. In this case, the use cases are for infrastructure and service use, to focus on real and actual needs from the community. There are 26 use cases in our work program, and they represent everything from making a specific data collection fit for sharing, or to implementing state-of-the-art software for data handling and data representation. Many of these use cases are also connected to monitoring programs in Germany, so they contribute data to monitoring, but not all of them. So looking at this may seem like an awfully fragmented way of doing things. But by working with the use cases, we find similarities in their needs. And sometimes these needs can be addressed by adapting existing processes that have proven right at another organization that can be adapted, learning by example. And they also, the partners have the possibility to move to a joint technology stack and service portfolio that is being built up in parallel. We try to avoid individually tailored solutions that will only work in one place, rather work out approaches that can be reused by others. And for lack of a better word, I would call these approaches blueprints. And I have brought one of the blueprints as an example for this talk. So this first example is harmonized data pipelines for occurrence data from collection data centers. It's an older case. It is something that was already developed in the German Federation for Biological Data, GFBio. That is a project that was funded between 2013 and 2022 by the German Science Foundation, DFG, and delivered a lot of services and procedures that we built on with NFDI for biodiversity as a legacy. So GFBio was a strongly science-driven consortium. It built a portfolio along the research data lifecycle. So everything from planning to publishing and archiving data from research projects. A couple of tools and processes were developed, but what I want to talk about right now is only one thing. One example, it is the harmonized data delivery from data centers to the joint GFBio portal. This is online. It allows access to data from 10 data centers that regularly deliver their data to this joint tool. And we have the biodiversity and collection data you see there is coming from the German GBIF nodes. These are collection data centers located at different research museums in Germany. In the course of the project, the 7 data centers, collection data centers, established harmonized data pipelines for data ingestion, data management, archiving, and publication. These data flows follow the principles of the Open Archival Information System, OAIS. And in the course of this work, the 7 data centers also prepared for Core Trust Seal certification as trusted data repositories. They also developed policy to archive additional reference data sets from external research projects. So I don't want to walk you through this in detail, but basically what they do is in the back end, the data centers rely on their in-house solutions of collection, data management, and editing systems, but they provide ABCD structured information packages regularly every 6 months with single fair records and this is being generated by the BioCase provider software and delivered with a persistent identifier assignment for download under a CC BY license. The access is organized via the GFBio data portal, where the data can also be used in a visualization, transformation, and analysis tool. And when researchers go to the portal, they can access the data from these 7 data centers, and they can also combine it with their own data sets uploaded. So the access is also supported by metadata as delivered via a GFBio instance of the BioCase monitor service. The data is also delivered to GBIF. Now, extensive documentation of the harmonization work and the workflows that have been negotiated among these 7 data centers are also available online, have been published. So it is the documentation is available as a precedent for others, and we are using this documentation presently as we work with other natural history museums who wish to mobilize data, and they can look at the documentation and adapt it. Basically, what the GBIF nodes in Germany do is they help them introduce the BioCase provider and BioCase monitor software to their workflows, which is often not the case, especially in the smaller collections at universities. And this work also serves to mobilize more data for GBIF, more German data for GBIF. So this is how we keep on using these blueprints. And the second example is work in progress. We think another interesting blueprint will come from current work on harmonized data pipelines in metabarcoding studies. This is going back to my previous slide on the use case projects we have in NFDI for biodiversity. And you see in red 5 actors, 5 stakeholders who are interested in who produce metabarcoding data. And we profit here from our partner networks, which provides different parts and pieces of the pipeline. So we have the Barcode of Life, the German node, German Barcode of Life, available as a central archive. One of our partners is Denby, the German Elixir node, who provides cloud services for analysis pipelines, bioinformatics. And we have 3 or 4 partners who volunteer to move their analysis software to the cloud and develop common workflows. The role of NFDI for biodiversity of the consortium is that of a facilitator in this process. We have a couple of use case managers who bring the parties together and organize the joint work. So the idea with this work here with these use cases is to provide a similar kind of documentation as in the case of the collection data centers, so others can review the precedent and adapt accordingly or use the tools that have been made available by the partners. So these were 2 examples from a very extensive work program we have in our network. Finally, I want to close with a vision on the common architecture that we have in view. It's called the Research Data Commons. We plan to move existing services to the academic cloud. Basically, what you see here is a concept that is elsewhere called platform as a service. That is also available. For example, it has been established in the Earth Science observation data. So we have an application layer at the top where users go and where several tools or data portals can be accessed by single users. And below that are different layers, technical layers, where data can be stored, transformed, and processed. We use the academic clouds in Germany. Ideally, this will be a multi-cloud environment. And part of our IT development efforts go into adapting existing tools to the cloud. For example, the diversity workbench data management system provide an instance for that for projects that they can just click for a project in the cloud without having to install it in their local data centers. For the experts among you, we also have a more technical view of the research data commons available. You will find that in the slides. So these are two stories I can contribute today. As you can see, we're not a consortium that heads straight towards a national atlas of living Germany or an inventory of national biodiversity. In fact, that would be much, the National Monitoring Center for Biodiversity we have in Germany is much more prone to do that. Both our initiatives have started about the same time in 2020, 2021, and we have already agreed to join our forces for the best possible degree to serve the people who need it with the best possible data. Our role as NFDI for Biodiversity is to provide infrastructure and practical tools that stakeholders can use. And the monitoring center works towards harmonizing the monitoring programs across Germany and provide a comprehensive professional portal for them. All in all, what this slide also shows, we are part of a much bigger partner landscape. Many of our partners are active in the initiatives you see here on the European and international level. So we don't want to reinvent the world, but we aim to make the existing solutions available for reuse in our stakeholder community. If you have questions about the governance or staff resources we have for this work, I will be happy to answer them and join either the group 2 for knowledge sharing strategies or the group 3 for governance. Thank you.
Thank you so much, Barbara. And thank you to all the 3 speakers. We are a bit late, we need to say that, but I don't want to shrink the discussion. So we have this 15 minutes question and answer, and therefore I see that there are already hands that are raised. I don't see the name. To Nestor. Nestor, please, you have the floor.
Thank you. I'm Nestor Fernandez. Barbara, I don't think we have met before. I am one of the leads of the work in one of our packets of Europabon, and I'm very happy. I am very aware of your initiative. So my question is precisely on what you mentioned on this relationship between NFDI for Biodiversity and the German Center for the German Monitoring Center, and how do you see those connections to happen, and in terms of infrastructure development, so transfers of data and metadata and so on, how can we learn from what you are doing with them?
Mm-hmm. Yes, I can, and David Eichenberg from NMZB is also here today. Basically, the short message is we plan to join forces best as possible because resources are low, and we should combine our strength. The concrete steps we have taken so far is that the head of the National Monitoring Center has been appointed to our strategic advisory board in NFDI for Biodiversity. And the speaker of our initiative, NFDI for Biodiversity, has been appointed to the Central Strategic Committee of NMZB. So we can, on the level now where both initiatives are pretty young, so we can make sure that the path decisions that are being made, that we know about that and can adapt accordingly. So we want best possible cooperation so that one initiative can profit from the other. the missions are different, right? So we're more about infrastructure, tools, services. So we don't strive to make any monitoring data complete, but to deliver blueprints how monitoring data can be mobilized for further reuse. While the NMZB, and David, you can say that yourself, your main mission is to harmonize the monitoring programs across Germany. And of course, that infrastructure or standards are an instrument to do that, but we're approaching the problem from two sides. So I see you nods. Is that okay? Please.
Yeah, I can fully confirm that, especially that the both initiatives are quite new, and it's very, very good that we can join forces already in this state of development of the organizations. And I can confirm that the collaboration is quite close and very promising. Yeah.
Yeah. It's interesting because we come from the science sector, right? So we talk to these monitoring actors because they want to mobilize the data for research purposes. They're ready to do that. And so we're kind of have a accelerator role maybe for standardizing a couple of data sets that are important for research right now, and they're willing to sit together to talk about that. And so we get, a foot in the door.
Thank you so much. Thank you so much both for question and for answer and contribution to answer. I don't know if there are other questions for also for the other speaker. I don't see at the moment any hand raised. So
there is a question in the chat, Alberto.
Okay, can you read the question?
Yeah, so there is a question from Petteri asking if this is a long-term initiative. Maybe Peter, if you want to, I think it's for Barbara.
Yeah, it was like a continuation of what you already told about this collaboration with National Biodiversity Coordination Center. So that are you also having this kind of long time span and the support from your
government? Yeah.
Government,
yeah. At present, the National Research Data Initiative is a 10-year pilot phase. It's very grassrootsy. It's very bottom up. The National Research Data Infrastructure Association has already 220 members from scientific organizations and collaborating institutions. So what the science ministers will evaluate in 2026 is the structure right? So there is a commitment from the science ministers to continuously fund a national research data infrastructure. And it's also very clear that this should be community-based. So we have the biodiversity community right now, earth sciences, social sciences, and many others, like 26 consortia. So we have functioning communities of practice, but to run a national research data infrastructure in the long term, we will probably have to consolidate a bit more over time. So the program for the first 10 years is clear to run these communities of practice, and then they will, we expect that money will be given for a second phase where consolidation takes place, and this gradually goes into continuous funding. The funding by the Science Minister Conference in Germany is a very, very good sign, because there is a constitutional instrument for co-funding, both by the federal state and the federal government, to co-fund activities of national importance. And they set out to do that, and they will continue to do that. The structure may consolidate a bit. So we already work across consortia to see which basic services we can run together. So we don't need to do it as NFDI for biodiversity, this academic cloud or multi-cloud environments, for example.
Thank you so much.